Good afternoon, everybody. This is Julie Beaver with my Math 626 Mathematical Problem Solving Problem Assignment Video Instructions. So, what I want to look at in this assignment is pre-calculus. I teach pre-calculus for a College in the Schools course, and one of my favorite things that we get to do every spring, so February, March, April, we spend about 3 months here, is trigonometry. So one thing that we start with that I want to make sure that my students are strong in is graphing trigonometric functions and discovering real-life applications involved in those functions. Now, as I go through this, I want to let you know that I'm on a mission trip with 30 middle schoolers, and it's closing in on dinner time. So if you hear some screaming in the background, everything is okay. It's just middle schoolers being middle schoolers. So here's the problem that I have chosen. I want to start making questions that I'm asking my students more open-ended. So it's not just graph this function, because that is great that they graph a function, but it doesn't involve as many higher order thinking skills as I would like them to have. And I just want to make sure that they can really work deeply with the content. So I also want to have them using technology. So Desmos is a tool that I have used that I'm very comfortable with. My students are one-to-one. Every one of them has a Chromebook, so I know that this is a tool that they can use and that they can learn to be successful with. So we're going to start using Desmos, and I want to create equations for 3 unique sine graphs, and they have to meet the following requirements. Now, the students have to actually write the equations, but they also need to have the graph involved. So there's where the Desmos comes. So they'll use Desmos to type in their equations and make sure that the graph of their equation actually does what they think it should do. So it's an easy way for them to check their work right away and also to make the connections between the equation that they're writing and the graph that they are seeing. And so they can monitor and adjust. And that just, again, takes the connections and the thinking level deeper. So here are the requirements that I want them to have. They must have zeros at 2 pi over 3 and 7 pi over 3. I picked the pi over 3s because they're just more challenging. Oftentimes when you get paper that is set out for radians, it's in full pies, half pies, quarter pies. Well, if they have to do it in thirds, that just takes it up a notch. And how are they going to break it down in the thirds? All 3 equations and graphs must have a different period. What I like about 2 pi over 3 and 7 pi over 3 is, again, it just doesn't come to them really quickly like a pi over 4 or a pi over 2. So they all must have a different period. What else that does is it says, okay, the graph doesn't just have to go through 2 pi over 3 and then go up, 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 come back down at 7 pi over 3. It could go up, down, up, down, up, down. It could go down, up. There's all sorts of ways that they could make this. One of the things that I feel we as teachers in this course have struggled with is we want to know the right answer. And this question right here takes it up and says there isn't just a right answer. There's an infinite amount of equations that could satisfy this question. So we're going to go with they must have zeros at 2 pi over 3 and 7 pi over 3. All 3 must have a different period. At least one must have a magnitude greater than 1. One must have a magnitude less than 1, and no magnitudes may equal 1, because that's too easy. And then at least one of the equations in the graphs must have a horizontal shift. I was thinking about doing a vertical shift, and really I could go there with an extension question, but the up and down, then how exactly does that work in with the 2 pi over 3 and 7 pi over 3? I think that would be a great question for some of my deep thinkers. and then I would just say it has to be x-intercepts at 2 pi over 3 and 7 pi over 3, which would be very interesting if that center line shifted up or down. So let's see, how would I introduce them to them and get their buy-in? Because my pre-calculus class is for students who are generally accelerated, and if they're taking pre-calculus, they really want to learn the mathematics. They want to go deeper. They thrive on going deeper. And so I would just, as I'm introducing it to them, say, here's what we're doing. We're going deep today. And then I would tell them there is not one right solution, that there are infinitely many. And so I want you to be creative, and let's figure out new ways that we could work through this, and how many different, you have to come up with 3. Could you find more? What else could you do? Is there a pattern? Also, if we wanted to do an extension, or if I was asking if it was an assessment, I really could say create 3 unique sine graphs, and then I could change it to create 3 unique cosine graphs. I could work with tangents, cotangents. There would have to be some change in some of the wording, but how exciting could this be for students and for me to see the depth of their learning as they go through in just a more open-ended way?